This is Geometry B, Unit 5, Area. Lesson 1, we're going to find the areas of parallelograms and triangles. All right, area, first we need to define what area is. Area, as opposed to, say, something like perimeter. Area is the space inside a shape. Okay, and we can estimate area by counting. So let's say I've got some irregular shape, and I want to estimate the area of the shape. I can simply count any square or mostly square inside the shape. If it's got more than half of a square, I'm going to count it. More than half of a square, count it. Okay, so I'm going to count all of these dots. And I can estimate the area of this irregular shape. That's really close. I'd say that's less than half, but that's more than half there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. I would say the area is approximately 30 square units. And all the units on area is always square because we're finding out how many squares fit. Now the most basic shape to find the area of is a rectangle. Okay, so let's say I've got a rectangle that's 2 units tall and 3 units wide. Okay, let's use our tools to draw here. So it's 2 units tall and 3 units wide. In this case, counting the squares is quite easy. But there's another bigger generalization that can be made that we're going to get to here. Okay, so the area of this 2 by 3 rectangle is 1, 2, 3, 4, 5, 6. So the area is 6 square units, 6 units squared. But you might be looking for a general rule, and there is one. The area of a rectangle can be found by multiplying length by width. In this case, 2 times 3, or 6 square units. So this is the first of our formulas for area, right? Now, if I do this, if I take and cut off, I'm going to take a pair of scissors and cut off this triangle right here. And I'm going to move it to the other side. Here's the shape that results when I do that. Okay, and the name of this shape is a parallelogram. Parallelogram. Parallel, it's made of 2 parallel sides. Parallelogram, double L, elogram. But because I cut off the corner of a rectangle and moved it to the other side, have I really changed the area? And the answer is no. You know, there's a Native American proverb that says only white men think that cutting top of a blanket off and sewing it on bottom make blanket longer. Right? And you don't change the area by cutting off a piece and putting it to the other side, right? So the same thing here. When we moved the triangle to the other side and moved it over here, we didn't change the area. The area is still 6 by 3, or 2 by 3. 2 by 3. It's still 2 by 3, but when we look at the 3, where's the 3? Well, the 3 is the base, right? It's the base. We call that the base. And the 2 is right here. It's not the length of a side, it's the length of a perpendicular measurement. 2, it's the height. So the area of a parallelogram is base times height. Base times height. And in this case, it is 2 times 3 again, or 6 square units. Okay? Now, for a final thing here, I can do this. What if I take a pair of scissors and cut right down this diagonal? Okay, and cut this piece off here, and that results in this shape, a triangle. Okay, by cutting it down the middle like this, I have effectively cut it in half. These two, we can prove that these two triangles are congruent. We know that the diagonal of a parallelogram divides it into congruent triangles. We could probably use side, 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 or angle, side, angle, or any other, many other rules to prove it formally. But there it is. So we've got a triangle that is now a half of the parallelogram. Triangle that's half of the parallelogram. And so the area of this triangle is, here's the base, which is 3. Here's the height, which is 2. So it's base times height, but we divide by 2. Base times height divided by 2. Or we could say 1/2 base times height, either way. Base times height divided by 2, or 1/2 base times height. In this case, it's 1/2 2 times 3. Half of 2 is 1. 1 times 3 is 3 square units. Okay? All right, so area is base times height divided by 2 is the area of a triangle. Okay? And so those are the two formulas that we're going to need to use. We're going to need to use those. Half base times height for a triangle and base times height for a parallelogram. All right, hopefully that helps.